The Grumman X-29 was an American experimental aircraft that tested a forward swept wing, canard control surfaces, and other novel aircraft technologies. The X-29 was developed by Grumman, and the two built were flown by NASA and the United States Air Force. The aerodynamic instability of the X-29's airframe required the use of computerized fly-by-wire control. Composite materials were used to control the aeroelastic divergent twisting experienced by forward-swept wings, and to reduce weight. The X-29 first flew in 1984. Two X-29s were flight tested over the next decade. Design and development: two X-29s were built by Grumman from two existing Northrop F-5A Freedom Fighter airframes after the proposal had been chosen over a competing one involving a General Dynamics F-16 Fighting Falcon. The X-29 design made use of the forward fuselage and nose landing gear from the F-5s with the control surface actuators and main landing gear from the F-16. The technological advancement that made the X-29 a plausible design was the use of carbon fiber composites. The wings of the X-29, made partially of graphite epoxy, were swept forward at more than 33 degrees. The Grumman internal designation for the X-29 was Grumman Model 712, or G712. Three surface design and inherent instability. The X-29 is described as a three-surface aircraft, with canards, forward-swept wings, and aft-strake control surfaces, using three-surface longitudinal control. The canards and wings result in reduced trim drag and reduced wave drag, while using the strakes for trim in situations where the center of gravity is off provides less trim drag than relying on the canard to compensate. The configuration, combined with a center of gravity well aft of the aerodynamic center, made the craft inherently unstable. Stability was provided by the computerized flight control system making 40 corrections per second. The flight control system was made up of three redundant digital computers backed up by three redundant analog computers. Any of the three could fly it on its own, but the redundancy allowed them to check for errors. Each of the three would vote on their measurements, so that if any one was malfunctioning it could be detected. It was estimated that a total failure of the system was as unlikely as a mechanical failure in an airplane with a conventional arrangement. The high pitch instability of the airframe led to wide predictions of extreme maneuverability. This perception has held up in the years following the end of flight tests. Air Force tests did not support this expectation. For the flight control system to keep the whole system stable, the ability to initiate a maneuver easily needed to be moderated. This was programmed into the flight control system to preserve the ability to stop the pitching rotation and keep the aircraft from departing out of control. As a result, the whole system as flown could not be characterized as having any special increased agility. It was concluded that the X-29 could have had increased agility if it had faster control surface actuators and/or larger control surfaces. Aeroelastic considerations. In a forward-swept wing configuration, the aerodynamic lift produces a twisting force which rotates the wing leading edge upward. This results in a higher angle of attack, which increases lift, twisting the wing further. This aeroelastic divergence can quickly lead to structural failure. With conventional metallic construction, a torsionally very stiff wing would be required to resist twisting. Stiffening the wing adds weight, which may make the design unfeasible. The X-29 design made use of the anisotropic elastic coupling between bending and twisting of the carbon fiber composite material to address this aeroelastic effect. Rather than using a very stiff wing, which would carry a weight penalty even with a relatively lightweight composite, the X-29 used a laminate which produced coupling between bending and torsion. As lift increases, bending loads force the wing tips to bend upward. Torsion loads attempt to twist the wing to higher angles of attack, but the coupling resists the loads, twisting the leading edge downward, reducing wing angle of attack and lift. With lift reduced, the loads are reduced and divergence is avoided. Operational history: the first X-29 took its maiden flight on December 14, 1984 from Edwards AFB, piloted by Grumman's chief test pilot Chuck Sewell. The X-29 was the third forward swept-wing jet-powered aircraft designed to fly. The other two were the Nazi Germany Junkers Ju-287 and the HFB-320 Anza-jet. On December 13, 1985, the X-29 became the first forward swept-wing aircraft to fly at supersonic speed in level flight. The X-29 began a NASA test program 4 months after its first flight. The X-29 proved reliable, and by August 1986 was flying research missions of over 3 hours involving multiple flights. The first X-29 was not equipped with a spin recovery parachute, as flight tests were planned to avoid maneuvers that could result in departure from controlled flight, such as a spin. The second X-29 was given such a parachute and was involved in high angle of attack testing. X-29 No. 2 was maneuverable up to an angle of attack of about 25 degrees with a maximum angle of 67 degrees reached in a momentary pitch-up maneuver. The two X-29 aircraft flew a total of 242 times from 1984 to 1991. The NASA Dryden Flight Research Center reported that the X-29 demonstrated a number of new technologies and techniques, and new uses of existing technologies, including the use of aeroelastic tailoring to control structural divergence, aircraft control and handling during extreme instability, 3-surface longitudinal control, a double-hinged trailing edge flaperon at supersonic speeds, effective high angle of attack control, vortex control, and demonstration of military utility. Aircraft on display. The first X-29, 82-003, is now on display in the Research and Development Gallery at the National Museum of the United States Air Force on Wright-Patterson Air Force Base near Dayton, Ohio. The other craft is on display at the Armstrong Flight Research Center on Edwards Air Force Base. A full-scale model was on display from 1989 to 2011 at the National Air and Space Museum's National Mall Building in Washington, D.C. Specifications. Data from NASA X-planes, Donald, Winchester, General Characteristics, Crew, 1 pilot, Payload, 4,000 pounds, Length, 48 feet 1 inch, Wingspan, 27 feet 2 in, Height, 14 feet 9 in, Wing area, 188.8 FTA squared, Empty weight, 13,800 pounds, Max takeoff weight, 17,800 pounds, Power plant, 1 General Electric F404 turbofan, 16,000 pound forces, Performance, Maximum speed, Mach 1.8, Range, 350 miles, Service ceiling, 55,000 feet. See also. Related development, Northrop F-5, aircraft of comparable role, configuration and era, Sukhoi Su-47, related lists, list of experimental aircraft. References. Notes Bibliography This article incorporates public domain material from websites or documents of the National Aeronautics and Space Administration. External links, X-29 fact sheet at nasa.gov, fact sheet, Grumman X-29 by the National Museum of the U.S. Air Force, X-29 photos, and X-29 videos at nasa.gov, X-29, aircraft with forward swept wings, Part 1, Part 2 at military.com.